Now we're going to work on some hyperbola problems. Once again, there are two standard equations. If you notice, the equations for hyperbolas and ellipses look almost identical, except the only difference is for ellipses, you have addition here. For hyperbolas, you have subtraction. But the key thing is in standard equations, they both have a 1 on one side by itself, no coefficients in front of the parentheses. Now the key is when we start working with hyperbolas to know which equation you have. Once again, this is going to be a left or right hyperbola. This is up or down. You figure out what A is going to be the positive number here, right? Because B is after the minus sign. With ellipses, A and B, you determine A was always larger than B. That's not true with hyperbolas. A is the positive number, B is the negative number. And for hyperbolas, we also have foci to calculate, and here's the equation for hyperbolas to calculate C, which tells you where your foci is. All right, so let's just dive in and do some of these. So we start out with this equation right here, the hyperbola. Let me show you what we're supposed to figure out. But once again, I have to do a little maneuvering here to get it to come up when I share. All right, here we go. So here's this hyperbola equation. They ask for the two vertices, the two foci, and asymptotes. You can look at these. Now these are pictures of the possible graphs, but the asymptotes are these dashed diagonal lines. It's not something new with hyperbolas. So vertices, foci, asymptotes, and then the sketch of the graph. So let's go ahead and just start working through these. So if you compare this to the, first of all, it's in standard equation form. I got a 1 here. I got my denominators are numbers, so I'm good to go there. If I look at my equations, this is going to be a left or right hyperbola, which means it's going to end up looking something like this. If I write down the standard equation, hopefully you can see H and K are going to be 0. So just like an ellipse, we call H and K the center of the hyperbola. It's going to be at the origin. It's pretty easy just to compare here and realize that A is going to be 5 and B is 3. And actually, while we're here, let's just do this. So we can do the foci. A squared's 25, B squared's 9. I don't think this simplifies. So let's go ahead and start graphing, and then we'll figure out what the vertices are, asymptotes, foci. Centers at the origin. So what you do is you have to know now if it's a left or right, or if it's a left or right, then that means you take A, and from the center, you go left or right. That's going to be a vertex, and that's going to be a vertex. So this is distance A on both sides. Then, in this case, A is left and right, since it's a left-right hyperbola. B, you go up and down. So this is the distance B. Then what you do is, with these 4 points here, you basically draw, it's almost always a rectangular box that connects these 4 points, and then you draw diagonal lines that go through the corners, the center, and the corners of the box. And these lines are called asymptotes. So, vertices. Negative 5, 0, and 5, 0. So the foci, C is the distance from the center. So in this case, it's going to be negative square root of 34, 0, and square root of 34, 0. And we'll just see what actual number square root of 34 is. It's like 5.8. So in this case, the foci are sort of outside, further on than the vertice. And then once you have these asymptotes, you can sort of draw, goes through the vertex, and then it begins to track the asymptotes. Now, how do you figure out the asymptotes? The equation of a line, of a straight line, we like to use the slope-intercept equation, where m is the slope, b is the y-intercept. Now, the nice thing is, for both these lines, when they cross the y-axis, they cross it at 0, which means for both of these, the y-intercept is 0. So for these two asymptotes, the equation is going to be y equals mx. M, if you recall from algebra a few years ago, is the slope. A lot of times we think of it as a fraction where the rise is on top and the run is on the bottom, which means, if you recall, you choose 2 points on the line. So for us, I'm going to choose the center and the corner, and the rise is how far up you have to go, and the run is how far over. So for this asymptote, I had to go up 3, and then to get from here to here, 1, 2, 3, 4. I had to go over 5. Those are both positive numbers. The slope of this asymptote is 3/5. So the equation of that line is y equals 3/5 x. Now, if you do this line, if you start here and go to here, the rise, I'll call this M1 for line 1. I'll call this line 2. The slope of line 2, the rise is 3 once again. But now the run, since we're going in the negative x direction, the run is actually negative 5. So the slope is negative 3/5. So the second line is negative 3/5 x. So basically, that's everything. A lot of stuff going on, a little bit messy, but hope everybody's able to follow. So let's fill in these blanks. The vertices were negative 5, 0, and 5, 0. Foci, negative square root of 34, 0, and positive square root of 34, 0. Asymptotes, the smaller slope, which in this case would be the negative slope. So y equals negative 3/5 x, and y equals 3/5 x. And now, which one looks correct? Well, I know it's got to be one of these two here, and obviously it's a lot narrower than this one, and you can see that the focus is pretty close to the vertex, so pretty sure it's got to be that one. All right, I see all green checks. That's good. All right, here's another one. So it's going right down the equation of the hyperbola. See if we can figure everything out. Y plus 3 quantity squared over 25 minus x plus 3 quantity squared over 9 equals 1. So hyperbola, it's in standard form. Here, the y, the 25 is with the y, so therefore that's a squared, that's b squared, and this is going to be an up or down hyperbola, so it's going to look like this. Now the center is hk, so let's write down the standard equation, y minus k squared over a squared minus x minus h squared over b squared equals 1. So the center, once again, you got to do the sort of what I call the opposite rule, right? H goes with the x plus 3, which means it's minus 3. K is with the y, it's plus 3, which means it's minus 3. So really, center of the hyperbola is going to be here at minus 3, minus 3. Now we know a squared is 25. So a is 5, b squared is 9, so b is 3. So with this information, I can go ahead and now sketch in all the information I need. So here's the key. Since it's an up or down, I go A and I move up 5 from the center and down 5. So here's 3. So there's up 5. Here's down 5. Then side to side, it's going to be 3. Then if you try and draw the box, now since I'm going up and down, do my diagonal lines through the center and the corners of the boxes. Since it's up and down, should look like this. All right, So they're going to ask me for the vertices. Which are these ones right here. And I moved 5. Now, so this point, this center is at -3, -3. When I moved up 5, or let's do this one first. I moved down 5. That made it -3, -8. When I move up 5, it made it -3, 2. Now the foci, my little foci equation, 25 plus 9, it's like 34 again. So now the foci is going to be sort of down in here, and this distance is going to be square root of 34. So we're at -3, and the y is -3, and I subtract square root of 34. And then the foci above is going to be -3 plus square root of 34. Now the asymptotes are a little tricky because since I'm not at the center, I'm going to have a y-intercept. Here's the way I'm going to do this. Let's do, this is line 1 and line 2. I can figure out the slope, right? So from here to here, I move up 5 and over 3. I need to figure out what B is. B is called the y-intercept, but I'm not sure what it is. Easiest thing to do is I'm going to take my center point and I can plug this in for x and y. And when I do that, I can calculate B. So I plug in -3 for y, -3 for x. This becomes -3 equals -5 plus b. Add 5 to both sides. Looks like b is 2. So therefore, my equation is y equals 5/3 x plus 2. There's one of my asymptotes. For number 2, I do the same thing. Now I know the slope is going to be -5/3, up 5 over 3. You notice -3, -3 is also on this other asymptote, so I'm going to plug that in for x and y. Do the math here. You have -3 equals 5 plus b. Subtract 5 from both sides to solve, and you get b equals -8. So this one, -5/3 x minus 8. And that makes sense because here we're saying the y-intercept is -8. Here we're saying the y-intercept is 2. Things look like they're correct. I guess we'll find out in a minute. So, vertices, smaller y value. -3, -8. And the larger y value, -3, 2. Foci, smaller y value, -3, -3 minus square root of 34. Wow, -3, -3 minus square root of 34. The larger one, -3, then -3 plus the square root 34. Smaller slope, which is that negative slope, y equals -5/3 x minus 8, and then y equals 5/3 x plus 2. So for the graphs, it's an up and down. It's got to be one of these two. And you can see, obviously, the center is this one right here. So this has got to be the correct answer. All right, let's see what we've got. And I see all green checks, which is nice. All right, different kind of problem. They give us a graph of an hyperbola, or I think it's n. They give us the graph of a hyperbola, and they want us to know or figure out the equation. So let's look at this, and let me go and write down everything we can figure out from looking at this. Now let me just tell you, well, let me write it down. First of all, this is a left or right. Let's just write down the equation, figure out what we're going to need to know. So if it's a left or right, we know the standard equation is x minus h quantity squared over a squared minus y minus k quantity squared over b squared equals 1. We know hk is the center, if we can figure that out. And we know a and b, well, a has to do with the vertices, b is sort of the other side of the box. So we need to figure out three things, the center and a and b, and then we can have the equation. So let's go back and look now and see what information they've given us, see what we can figure out from the graph. Obviously, we can find the center, right? The center is going to be halfway in between the vertices. In this case, the center is at the origin. So it's 0, 0, hk. We know the distance a is from the center to the vertice. Looks like the vertex here is at 6. So I'm guessing a is going to be 6. Now we need to figure out b. B in this case is like an up and down. We have no information about up and down, but they do give us the focus. The distance from the center to the focus is c. So we know c is going to be 10. And as it turns out, if we know a and c, we're going to be able to figure out b. So a is 6, c is 10. I need to know b. Well, I know with a hyperbola, c squared equals a squared plus b squared. So 10 squared equals 6 squared plus b squared. This is 100 minus 36. Turns out b is 8. So now I think I have everything I need for my equation. I'm at the center, so there's no h and k, so it's just x squared over a squared. A is 6. X squared over 36 minus y squared over b squared. Here's an example where actually b is bigger than a, but the key is a is a positive number. That should be the equation of the hyperbola. So let's see. X squared over 36 minus y squared over 64 equals 1. All right, green check. All right, here's another one. So that was number 19. So this is number 20. Let's write down what information we can get from here. Can we figure out the center? Well, the center is always halfway between either the vertices or the foci. First of all, it's an up or down, which means the equation is going to be y minus k quantity squared over a squared minus x minus h quantity squared over b squared equals 1. I can figure out the center. Let's just figure out where the middle between the vertices. So I'm at minus 5, minus 2, minus 5, minus 4. So in the y direction, there's a distance of 2 between the vertices. So halfway is 1. So basically, I know the center is minus 5, minus 3. And I also know the distance A, because A is from the center to the vertice. So A is 1. Now I also need to know B. I don't know B, but in this case, once again, since they gave us the foci, I know C. C is the distance from the center to the foci, and it's going to be 2. And I think with that information, I can go and all I need to do is figure out B, then I think I'll be able to determine the equation. So I don't know B, but I know C squared equals A squared plus B squared. C squared is 4, A squared is 1. Looks like B squared is going to be 3. Actually, all I need is B squared. I don't need the actual value of B. So I think I have what I need. So y minus k, k is negative 3, minus a negative 3 is y plus 3 squared over a squared, which is 1, minus x minus h, x minus a minus 5 is x plus 5 squared. B squared is 3. Now normally I will not write a fraction of minus 1. I'll just write y plus 3 quantity squared. So y plus 3 quantity squared minus x plus 5 quantity squared divided by 3 equals 1. And that is correct. All right, probably just a couple more. Yep, a couple more. So now we have the ones where they give us information. And with the information they give us, they want us to find the equation of the hyperbola. So this is going to be number 21. What do they tell us? They give us the foci, which is basically 0, 6, and 0, negative 6. And they give us the vertices, which are 0, 1, and 0, negative 1. Oh, they tell us the center is at the origin. All right. So like always, just to keep things straight so I don't get disorientated, I'll graph this stuff and see what we got here. Here's the center. So the vertices, 0, 1, 0, -1. Whoops. So that means obviously it's going to be an up or down hyperbola. Foci turns out is so from this stuff, what we really know is we know the center is 0, 0. We know A is the distance from the center to the vertice. A is 1. I know from the center to the focus is C. Now I can figure out B from knowing that C squared equals A squared plus B squared. So C squared's 36, A squared's 1 plus B squared. Looks like B squared is 35. And I think now I have what I need to write the equation. Oh, so this is an up or down standard equation. Y minus K quantity squared over A squared minus X minus H quantity squared over B squared equals 1. Now I think I have everything I need to plug in to get the equation. H and K are 0. They're both 0. A is 1, so A squared's 1. Let me just not write anything here. X squared, B squared is 35. So it should be Y squared minus X squared over 35 equals 1. All right. Y squared minus X squared over 35 equals 1. All right, last problem. 22. Let's write down the information we're given. Looks almost like the last one. Centers at the origin. So H and K are 0, 0. Foci, -7, 0, and 7, 0. Vertices, -5, 0, and 5, 0. So if I draw a little sketch here, vertices 5, 0, 1, 2, 3, 4, 5. That's a vertice. So actually it's going to be a left or right parabola or hyperbola, which the equation is x minus h squared over a squared minus y minus k squared over b squared equals 1. So I know A is 5. I know the center is 0, 0. I need to know B. I don't know B, but I know C, because C is 7. So like we keep doing, we use this equation. 49 equals 25 plus b squared. B squared equals 24. So I think h and k are 0, 0, so x squared over a squared minus y squared over b squared, which is 24, equals 1. So x squared over 25 minus y squared over 24 equals 1. And I think that is the last problem, and it is correct. So that finishes the review, and I will now stop this video.